Okay, this video is going to be a quick primer on how to read DNA. In other words, how to take the sequence that we find from the DNA. We'll first have it transcribed into RNA, and then we're going to take the RNA code and try to turn it into amino acids. So, how do we turn the DNA code into the protein? The first step is what we're going to do is we're going to take and we're going to translate the mRNA to create the proteins. So, once we've already transcribed the mRNA, now what we can do is we can get sets of 3. These are what we call the codons. 3 nucleotides together is a codon. And as it turns out, if you group these things together, we can code for all 20 amino acids. The grouping of the 3 nucleotides is called the reading frame. So we could imagine, for example, a sentence. Let's take a look at this sentence here. The 3 nucleotides together is going to be called a codon. So here's the sentence. Why did the red bat eat the fat rat? If we had no spaces in here, it would be kind of hard to read this sentence. However, once we put in the spaces, once we put in the reading frame, it reads very nicely. And I intentionally used English and also just 3 letters in a group in order to give you an approximation of what we're talking about here. It just makes it easier to see. But you can imagine what would happen if we started with, instead of the W, what if we started at the H and tried to group them together by 3's starting at the H? HYD, well, that doesn't make any sense. IDT, HER, well, there's the first word I actually recognize. But you notice the reading frame is critically important. All proteins begin with the same 3-letter code. It's always going to be AUG. So let's actually take a look at how we read the genetic code. So remember, there are a total of 64 different combinations, but there's only 20 amino acids. So some of the amino acids, you'll notice, are used more than one time. So for example, CUU codes for lysine, but so does CUC. So there are 64 codons, and 61 of them specify an amino acid. Some of them specify a stop. These stop codons are how we know that the gene has ended. Now let's actually take the first codon that we talked about, the AUG, and see how we would read it. In order to read this table, the first step is to find the first letter. And so what we've got is A is our first letter. So we're going to find A along the left side. There we go, there's A. So we know it's in this group. We can actually see these 2 lines here delineate this particular group. The second letter, U. Well, so that's going to be in this column. So now we've narrowed it down to these 4. And the only question is, what's the last letter? It's a G. See, if we read over from the G, this is how we get the last letter here. And so that's the letter that we're going to read. AUG gives us AM, or methionine. Okay? That's how you read your genetic code. And you can take any genetic code that you have, any mRNA sequence, and you can read it. For example, you might want to practice looking at this one. I've given you the answers here. ACU, CCU, GAG, GAG, and AAG. See if you come up with the same code as is shown here. Okay, good luck with your translations of the genetic code.